Hello everyone, Siddharth this side, and in this video we will be solving another question on Geek for Geeks, which is reverse level order traversal. So the previous question that we had solved earlier, we just have to do the reverse of that. So how we can solve this question? Let's see. So we just have to modify something into our level order traversal, and we will able to solve this question as well. So let's see what is level order traversal first. What we had done there. So 1, 2, and 3, then 4 and 5. So what should be the level order traversal for that? It should be 1, then 2, then 3, then 4, then 5. Now what we have to do? We have to print the level order traversal from the last level. So for this is 3 to 1, this is 40, 60, 20, 30, and 10. So we have to print not from start level 0, we have to print from last level. So we have to print 4, 5, then 2, then 3, then 1. Now if you will try to think how we can solve this question. So one approach that I had come with when I was solving this question is that suppose instead of using queue, we can use stack only. So what we do, first we will add this node into the stack, and then we will have a peak of this. We will have a peak of this node. We will have a peak of this node, and then we will try to see it right child first. Why we try to see the right child first? Because stack uh, we have to, like, stack will work on a principle of last in first out. So the element which we will be adding in the last, it will come out first. So if we add 2, then it will come later than 3. That's why we have added 3. So because we have to print from here, so we will add 3, then we will check for its left child, and then we will add this. Then again we will have a peak for our current top node, which is 2, which then we will see it's for left child, then we will see it for left child. First we will see for its right child, then we will see it for its left child. But there is a problem with this approach, is that uh, while since we have to apply a loop outside this, so if we apply st dot size should be greater than 0, then this loop will continue forever, because the size of the stack will not change, as we are adding the node continuously without popping them out. So this is the major problem with this approach, and I am sure that you guys will also think of this approach for the first time. Now let's see what we can modify here. We will be using stack here, but instead of stack, additionally, with the use of a stack, we will be using queue as well. We will be following the level order traversal. We will add 1, then we first, instead of left, we will be adding 3 into a queue. Now after adding our nodes, we will put the current node into a stack. So what we uh, what we uh, uh, what we does in our level order traversal, first we will push our current node, then we will see for its left and right child. So first, after pushing our current node, we will pull it out. So after pulling out, we will be having 1. Now we will add this to into a stack. Sorry, into a stack, we will add 1 here. So after adding 1, we will move on to the right child first, and this is the intuition that I had already told why we will be adding the right child first. So after adding this right child, sorry, after adding this right child into a queue, so we will be adding 3, then we will be adding 2. Now after again we will be polling this 3 out. So after polling this 3 out, now we just have to add this into a stack. So now you can clearly see that our stack is following the reverse lever traversal. So first we will be adding 1, then we will be adding 3, then we will be adding 2, then we will be adding 5, then we will be adding 4. Now we will we will take out the elements from our stack one by one, and we will add that into our array list, and this will solve our problem. So let's go. So first what we have to do, we have to make a stack and we have to make a queue. So let's make a stack first. So stack of integers, st is equals to new stack. So this will give us a stack. Now we have to make a queue as well. So ue the queue we have to make for the node data type, and this should be queue equals to new linked list. Now what we have to do, let's make an array list which we have to return. First check for the base case. So if node is equals to null, in this case what we have to do, we just have to return an empty array list. So return new array list. So this will return an empty array list. Now we have to make an array list that we have to return. So array list integers, let's named it as result new array list. After doing this, what we have to do, we just have to add a current node into a queue that we do in a uh, level order traversal. So we will be adding queue dot offer, current node it is node, and after doing this, let's apply the while loop. So while q dot is empty. So now what we have to do, we have to pull out our current node. So node current is equals to q dot poll. This will give us the top node of the queue. Now after doing this, we have to add this current node data into a stack. So st dot push. So after what we have to push, current dot data. Now what we have to do, after doing this, we have to check for the left and right child. First we will be checking right child. So if current dot right does not equals to null, in that case we just have to add that. So q dot offer current dot right. Now after doing this, we have to check for the left child as well. So current dot left does not equals to null. So in this case as well, we have to add that into a queue. So current dot left. After doing this, we will be having a stack with the order of our reverse level order traversal. Now we just have to pull the element one by one from the pop the element one by one from the stack, and we have to add that into our array list. So while st dot size is greater than 0. So in this case, what we have to do, we have to add result dot add. What we have to add, we have to add st dot pop. Okay, so this will store. Now we will be having a array list that will store a reverse level order traversal. Now let's return it. So result. Now let's try to run this code. So I think everything looking fine. Okay, now let's try to submit this. So all the test cases have been processed. So thank you. See you in the next video. Bye.